Hey guys, welcome to Science 6.4a. We're going to be going through pages 144 to 149 today. You guys might think that I'm totally crazy, but this stuff is fascinating, okay? I was like, what? When I was reading through this. This is cool. Okay, so we are on heat and changes of state, okay? Let me give you what you're looking for today, and then I'm going to start to talk through some things with you so that you can understand what you are reading, okay? What you need to do is you need to explain to me in 3 sentences what is freezing point depression. So I'm on page 145. What is freezing point depression? Number 2, you need to give me 3 sentences on latent heat. Latent heat. 1 sentence in your own word of heat of fusion. What is heat of fusion? Okay, next. 3 sentences on how evaporation works. How evaporation works. 1 sentence on the difference between volatile and non-volatile liquids. 3 sentences on how boiling works. 3 sentences on how pressure affects boiling. How pressure affects boiling. 2 sentences on how a pressure cooker works, because after you learn how pressure affects boiling, you'll learn how a pressure cooker works. One sentence in your own word of what is boiling point elevation. 1 sentence in your own word about what is heat of vaporization. And 3 sentences on why we sweat. Why do we sweat? Sudar, right, is a word. That's on page 149. Fascinating. Okay, so let's get into it. So look what it says on the first paragraph of page 144. On Earth, matter ordinarily occurs in one of 3 states. We know that, solid, liquid, gas. And then we look at the kinetic theory of matter. That leads us to expect that an object state depends largely on its temperature. And it's true, it does, you guys. But listen in. Okay, so look, what we're saying is that if something is very, very hot, it can turn into a gas. Okay, if it starts from a liquid, you can melt it down and turn it. If it starts from a solid, like let's say gold, right? You can melt it down and turn it into a liquid. You can take out the dirty stuff. And then you can put it back in a solid, right? You have water. It can start from ice and it can melt down to water, liquid water, and then it can evaporate into a gas, okay? And it all depends on the temperature of it, we say, right? Which is true. One of the biggest factors, because of the kinetic theory of matter, is the temperature to it. But there's a little bit more, okay? And that's what we're getting into today. There's a little bit more involved in changing the state of matter of a particular material, okay? So look what it says. Because thermal energy affects the motion of the molecules of matter, a change from one state to another involves the addition or subtraction of thermal energy, okay? So there's another type of energy also that's going to be applied here that is necessary to change one thing from another thing, and this one state to another state, and that is what this is all about. It's not necessarily just about changing the temperature of the material to change the state of it, okay? So it says energy added to matter can cause the substance to change from a solid to a liquid to a gas, or even a solid directly to a gas. Melting and freezing. I'm not going to read the entire thing, don't worry, but I want to give you a solid introduction. If a solid is heated to a certain point, its molecules move fast enough to overcome the cohesion that holds them together. So you hear that? First of all, what happens? What's happening when you're melting and freezing something? If you're going to melt something, a solid has to be heated to a certain point where the molecules can break through the cohesion. They're moving so fast that they get jolted, okay? So, for example, I'm sitting on a chair. This chair is actually getting a little unstable. If I were to move this chair back and forth, back and forth, back and forth, I would eventually break the cohesion of the chair. The exact same thing is happening when temperature is applied to a solid to break up the cohesion of the molecules for it to melt. They can then move freely over each other, forming a liquid. The changing of a solid into a liquid is melting or fusion. The temperature at which the melting occurs is the melting point. The change of a liquid into a solid is freezing. And the temperature at which this occurs is freezing point. So this is the stuff that we already know, right? At one point it freezes, at one point it melts. Usually the freezing point and melting point of a substance are the same temperature. The process is merely proceeding in opposite directions, okay? So look at example 6.19. You have 1 gram of water at 0. It has to, you're about to learn this, there's energy involved. It has to give up energy for it to freeze. If it's already frozen, it has to receive energy to melt, okay? So what is that all about? Okay, I am going to read you page 145, and I'm going to talk you through this first part, and then the rest of it, that will give you a good understanding, enough for you to go through the rest of it by yourself, okay? But it's super interesting. Okay, it's super interesting, and it applies to so many different ways, and I believe that walking you through page 145 is going to give you a good foundation for that, and then I'll teach you what to do for this example 6.4. So, freezing point depression. The freezing point of a liquid is lowered by the addition of solutes. Okay, so this is very interesting. Look, so let's say you have a freezing point of 0 for water. Okay, your freezing point is 0 for water. If water gets down to 0 Celsius, it will freeze. That's a problem when you're like in a car or something, because you have water going through your pipes. What if they freeze? That happens. So what have mechanics invented for a car? Antifreeze. You apply a solute that brings down the temperature the freezing point temperature, so that maybe the water won't hit it. Okay, so now instead of it's 0 degrees that it'll freeze at, it's negative something degrees that it'll freeze at. So look what it says. This phenomenon is called freezing point depression, that you can lower the freezing point. For example, antifreeze, that's what I'm talking about there in the car, can be added to water to lower its freezing point, because the solute molecules get in the way of the water molecules and make it more difficult for them to come together and cohere. So what's happening is that water will still freeze at 0, but at 0 it starts to look for more water molecules to cohere to that also want to freeze, and this antifreeze is in the way, okay, and it can't cohere well enough. More energy must be removed for the liquid to freeze. The freezing point is decreased. Antifreeze is used in cars partly to keep the water in the engine from freezing in the winter. Salt, which also lowers the freezing point of water, is often used in winter to melt ice on public roads. So if there's ice on the roads, they throw salt, a lot of salt, and that will get into the water molecules and break them up. Okay? What is latent heat? Once a solid reaches its melting point, its temperature, this is the part I love. Look, once a solid reaches its melting point, its temperature will not change until all the solid has melted. What? No matter how much heat is added. Okay, well, let's just read through it and make sure you understand. The temperature does not rise because all the thermal energy observed is to loosen the cohesion between the molecules. To change a solid into a liquid requires a great amount of heat. But that heat does not produce a rise in temperature. It is entirely used in melting the solid. So what happens, like what I said, it's not just temperature. Because now the heat must transfer into another type of energy to be breaking down those molecules. Because if it just stayed heat, the temperature would keep rising and rising and rising, but it doesn't, okay? So let's say that you have like a, let me see if this example is being used. It will be, but look. Let's say you have a huge block of ice, okay? And you put that huge block of ice, let's say like in a pot on the stove, okay? You start to heat it up, and you're taking the temperature of the ice. You heat up the stove is producing thermal energy applying to the ice, and it's getting it to the temperature that it's ready to melt. Okay, it starts to melt because the heat, the thermal energy is breaking down those molecules. But the ice cube cannot get hotter, okay? The ice cube's temperature will not become hotter until all of it is melted. Turned it from a solid into a liquid. Why? Because all that heat that is going into it cannot be used to raise the temperature. It can only be used as energy to break down the cohesion. Okay? So it's like filling compartments. Like let's say, let's say that here's your ice. Here is the heat being applied. When you apply heat to something, usually it raises its temperature. But in this case, the goal of applying the heat is to change it to a liquid, right? Okay, so let's put 3 compartments here. There's like 3 steps. It's basically 3 steps. The heat is applied, which gets it to its melting point, okay? So the heat is being used to get to the temperature to its melting point. As soon as it gets it to its melting point, now all the energy is used to melt it, not to raise its temperature anymore. Then, after it's melted it all, it can raise its temperature. Okay, so those are the 3 steps that it has to go through. Heat is used to get it to its melting point. Then heat is used to break it down. Then heat is used to raise its temperature again. To me, that is super interesting. So look what it says on the next part. Because the heat used to melt a solid produces no rise in temperature, that heat in the middle that I just showed you, the heat that's used to melt it, that's called latent heat. Latent refers to something that is present but not visible, okay? Why is it present but not visible? Because heat is being applied as an energy breaking down the cohesion, but it's not seen in a rise in temperature, okay? So, therefore, latent is the hidden heat absorbed or released when a substance undergoes a change of state. So, like if you look at figure 6.19 again, water, let's start with the ice. The ice wants to melt into water. It's going to receive 334 joules, okay, to melt it. So look, again, let's do the heat here. You have, it got it to a temperature. This is the latent heat. And how much latent heat? 334 joules of it, okay? That's going to get it there to melt that thing, okay? That it needs to receive that amount to melt it all. As a solid changes into a liquid, the molecules of the solid absorb thermal energy so that they speed up. Their greater energy enables the molecules to overcome the strong cohesive forces between them, allowing them to assume the characteristics of a liquid. The latent heat required to change a given mass of a solid into a liquid without changing its temperature is called the heat of fusion, okay? So they're basically almost synonymous. This latent heat is invisible heat. This 334 joules is its heat of fusion. The latent heat required to get this to turn into a liquid. Okay? You can look at table 6.2. Here is your heat of fusion. So let's look at water. 0 is the melting point. It takes 334 joules per gram to melt it down. Okay, and then there's different ones for each substance. So look at page 146. I'm going to finish up reading here, then the rest is you. For example, a thoroughly stirred mixture of ice and water in a container will have a temperature of 0. If we heat the mixture, we find that no matter how much heat is added, the temperature of the mixture remains 0 until the last piece of ice melts. Only then can the temperature rise. Melting 1 gram of ice at 0 degrees to form 1 gram of liquid water at 0 requires 334 joules of heat to overcome the cohesion of the ice molecules. After the ice has melted, only 4.18 joules of heat per gram are required to raise the temperature. Blah, blah, blah. That gets too much into specific heat. For liquid water to become ice, it must lose its latent heat. To freeze, a substance must lose latent heat equal to the heat of fusion. Every gram of water gives off 334 joules of heat when it freezes and forms ice. When the thermal energy of liquid water is thus reduced, its molecules cohere and form a solid. Okay, so that is what is happening when you're melting things and freezing things. Then you're going to get into, I decided to skip 6.4. It's not super much the focus right now what 6.4 is, because you have to go back to page 129 to get the formula. It's not necessarily what they're talking about in this lesson right now. Okay, then you're going to talk about evaporation. Look what it says. If a glass of water is poured onto a hot sidewalk, the water will quickly disappear. The water still exists, but it has changed into water vapor, the gaseous form of water. The change of a substance is called evaporation, and you're going to go into why it is evaporated. Super interesting. And then how does it boil? Now the boiling thing is probably my favorite, okay, because I never knew that's how water boils. So if you don't understand that, what you can do, because I'm going to suggest you to do this in the Revelation as well, send me an audio asking me in my own words, am I understanding correctly what happens when you're boiling something and how the pressure affects it? Tell me, ask me. Because I think if I can understand this, you guys can understand this too, because I did not look up any more information, just what's in this book, okay? Because I thought that it was said very, very well, okay? And then I'm going to explain that in history as well, that you can do the same thing to make sure that you understand about neo-orthodoxy, okay? And then don't forget about the sweating. Have fun, enjoy. Let me know if you thought it was as interesting as I did. Okay? If you don't remember the things that you need to write down, go back to the beginning of the video where I give you the list. Bye.